This video is for Chapter 3, Section 2, Proving Lines Are Parallel. In the previous video, Chapter 3, Section 1, we studied what happens when parallel lines are crossed by a transversal. Today what we're going to look at is lines that are crossed by a transversal that we don't know are parallel, and what are the requirements in order to make that determination. So for example, in this picture here I have four different angles, angle 1, 2, 3, and 4, and lines M and N with transversal K. At this time, none of these angles are congruent and none of the lines are parallel. We can say that angles 2 and 3 are corresponding, angles 2 and 4 are same side interior, angles 1 and 2 are alternate interior, and none of those things have any relationships. We actually do have one relationship where I misspoke. Angle 1 and angle 3 are vertical angles and we know they are congruent. They are across from each other. The vertical angle theorem tells us they are congruent, but it doesn't have anything to do with lines M and N. So what we're going to do is we're going to first start off thinking about what would happen if we were told that angle 3 was congruent to angle 2. So then the question becomes, does this create parallel lines? Well, imagine that we built line K, the transversal, and we measured out 70 degrees and then started drawing line M. And then we came down here from line K and measured out 70 degrees and started line N. This would be generally accepted that yes, this would create parallel lines. So in our previous lesson, if we started with parallel lines, angles 2 and 3 were congruent by the corresponding angles postulate. Now we're making the claim that if angles 2 and 3, corresponding angles, are actually congruent, then we can make the conclusion that the lines are parallel. Well, this is just the converse of what we said. So we have what is called the converse of the corresponding angles postulate. If two angles are corresponding and they are congruent, then the two lines cut by the transversal are parallel. It's important that we study converses because we studied the vertical angle theorem a few days ago, which says if two angles are vertical, then they are congruent. But the converse of that doesn't work. If two angles are congruent, then they're vertical. So there is no converse to the vertical angle theorem. However, there is a converse to the corresponding angles postulate. If the angles are congruent, then we can say the lines are parallel. We're just changing what comes first. Okay, now that I've taken away the markings from our problem here, let's look at what if something else was true. What if instead of 2 and 3 were congruent, what if we start with angle 1 is congruent to angle 2? So this piece of information is given to us. Now, those are alternate interior angles. So the claim is, does this cause the lines to be parallel? Well, we know that if 2 and 3 were congruent, we could say yes, because we just had that. We had the converse of the corresponding angles postulate still on the screen. Now, I know that 1 is congruent to 2. We decided this to start the problem. I also know that 1 is congruent to 3. Because those are vertical angles. So this leaves me wondering, what conclusion can I make? 1 is congruent to 2. 1 is also congruent to 3. So, therefore, my conclusion is angle 2 is congruent to angle 3, using the transitive property. Now, this is not a formal proof, but rather a lesson proof. We are looking at this, we are agreeing, this is definitely true. If 1 is congruent to 2 and 1 is congruent to 3, 2 is congruent to 3. So therefore, starting with 1 is congruent to 2, we can conclude that the lines are parallel. So why go through all this? How about let's make a statement. If alternate interior angles are congruent, then the lines are parallel. Well, we know that if the lines are parallel, alternate interior angles are congruent, so this just sounds like another converse. The converse of the alternate interior angle theorem is also true. If two angles are alternate interior angles and they are congruent, then the two lines cut by the transversal are parallel. Okay, this leaves us with only one other possibility. What about the converse of the same side interior angles postulate, or the same side interior angle theorem? Now, let's ignore for a second the markings on here, and let's go with a different thing given to us. Okay, what we have left is the converse of the same side interior angle theorem, which says that if two angles are same side interior angles and they are supplementary, then the two lines cut by the transversal are parallel. We've removed the markings from this, and we're going to take a look at these two statements right here. Let's start with if measure of angle 2 is 80 and the measure of angle 4 is 100. Together that adds up to 180. This gives us my criteria. They are supplementary angles and they are same side interior. One of the facts that we also know about this problem is that angles 3 and angle 4 have to add up to 180 because they form a line, adjacent angles that form a line. The measure of angle 3 plus the measure of angle 4 equals 180. Now, with some substitution, the measure of angle 3 plus 100 equals 180. And with some subtraction, I have the measure of angle 3 is equal to 80. Well, we now have linked. Measure of angle 3 and measure of angle 2 both have a measure of 100 or of 80 degrees, so they're congruent. By the definition of congruent, two angles with the same measure are congruent. And we've done it again. We have made angle 2 congruent to angle 3, which gave us corresponding angles. So now we know that this is always true. We can always go back to corresponding angles postulate. So therefore, the converse of the same side interior angles theorem works. These are the three ways to prove lines parallel. And now we're just going to look at how we will use this information. We now have 16 angles, 4 lines, M, N, J, and K. What we're going to do is look at some given statements and see what can we conclude. First of all, what if angle 1 was congruent to 5? Angle 1, angle 5. First is, let's figure out what's their relationship. Well, they're corresponding angles, and the transversal is M. So we have congruent corresponding angles. That creates parallel lines. My conclusion is J is parallel to K by the converse of the corresponding angles postulate. How about 6 and 16? Here's 6, here's 16. Now, their transversal is K. Very important to make that decision first. And they are on alternate sides, one from the top to bottom. They are in between lines M and N. These are alternate interior angles. Got it. Congruent alternate interior angles. That makes lines parallel. Conclusion, M is parallel to N by the converse of the alternate interior angle theorem. Let's try another one. What about angle 6 is congruent to angle 8? Well, 6 and 8. Well, those are vertical angles. Vertical angles don't create parallel lines. Okay, no parallel lines. These were vertical angles. How about if 1 and 12 are supplementary? 1, 12, well, they're in between M and N, so they're interior. J is the transversal, and they're on the same side. These are same side interior angles. I have same side interior angles that are supplementary. Conclusion, lines M and N are parallel again by the converse of the same side interior angle theorem. All right, let's try one more. What about if angle 3 is congruent to angle 15? Here's 3, here's 15. it kind of looks like they're corresponding angles. This is a common mistake that students make. We think of them as corresponding angles. They're both in the upper left corner. Where's their transversal? What line touches angle 3 and angle 15? Well, M and J make 3, N and K make 15. There's no transversal. Conclusion: there's no parallel lines. There cannot be a parallel lines unless we have a transversal that is creating the certain types of angles that we look for. Our final example is going to be involved. What if we wanted to make the lines parallel using these properties and theorems here? For example, if angle 2 was 11x and angle 9 over here was 7x, what value of x would make them parallel? Okay, well, 2 and 9, they're not alternate interior, they're not corresponding, they're not same side interior, they're none of these three. And what do we know? Well, let's assume the lines are parallel and see what we can figure out. Let's just pretend the lines are parallel for a second. M and N. 2 is related to 10. 9 is not. 9 is vertical to 11. Now we have something to work with. 9 is vertical 11. 11 and 2 are same side interior angles. And if we want these lines to be parallel, 2 and 11 better add up to 180. Here we go. 9 and 11 are the same because they are vertical angles. 2 and 11 are same side interior angles. So we need them to be supplementary. If we can make them supplementary, the lines will become parallel. So let's make them supplementary. 2 is 11x. 11 is 9 and 9 is 7x. So 11 is 7x. That makes 18x and x ends up equaling 10. So if x equals 10, the lines will be parallel. If x equals anything else, then the lines won't be parallel. So if x equals 10, we create parallel lines. That's it for this video lesson, and then this is set for you to attempt assignment number 4.